I will show you today how to solve for the velocity of the point D, B, C, and E using only the IC, so instantaneous center of zero velocity. Okay, we will not use the vectorial equation, only the IC. So first step will be to look at the road BDA. BDA. Okay, so the road BDA. Oops, let me draw that. That's the road BDA. Okay, what do we know on the road BDA? At A, we know the velocity of the point A, that is 4 meters per second. Okay, we have the point D. We know that the distance between D and A is 0.3. And we have the point B. And we know that the distance between B and D are 0.25. The velocity at B, we don't know the velocity at B, but we know that the velocity at B will be horizontal. There. So the velocity VB. And based on those two velocities, we can find the IC of the road BDA. So we draw the perpendicular line to VB, perpendicular line to VA that are going through the point A and the point B. And that's the IC of the road BDA. Okay. We have a little triangle 3, 4, 5. Okay, it's there. So the 5 is on this side. The 3 is parallel to this side. And the 4 is parallel to this side. Okay, so it means that this side will be equal to 3 divided by 5 times the maximum distance, that is 0.55. Okay, so we have the little triangle 3, 4, 5. So it means that our triangles is proportional to the 3, 4, 5, but with bigger dimensions. So if this one is 0.55, this dimension is 3 divided by 5 times 0.55. This is equal to 0.33. And this side is parallel to the 4, so 4 divided by 5 times 0.55. And this side is 0.44. Okay, so now that we have these dimensions, we can find omega of the road dB. We know that VA is equal to the RA from the IC of BDA, time omega BDA. We know VA and we know RAIC. So we have omega BDA, that is equal to VA, the 4 meters per second, divided by the distance between the IC and the point A, that's 0.44. So we got omega BDA, that is equal to 4 divided by 0.44. That's 9.09 rad per second. Okay. I think my blue pen will stay stuck. I don't know, sometimes it's like this. That's okay. Now that we have omega BDA, and which direction is omega BDA? VA is going down, VB is going to the right. So omega BDA will be in these directions. Okay, so that's in the negative directions if you want to draw the directions. We can find VB because we have VB that is equal to the omega BDA time RB from the IC, and we know B from the IC, that's 0.33. So VB is equal to 9.09 times 0.33. We got VB times 0.33. That is 3 meters per second, and it's going to the right. Okay. And D, the point D is on the road BDA too. So they have the same IC. So the IC is there. So we can draw a line. And VD is perpendicular to this, going down because that's the same rotation, and that's VD. So if we find RDIC, we can find VD. So let's see what do we need to find this. I will make this one a little bit bigger. We will need that. Okay. We need some angles. Choose other colors because we will be inside this triangle. Okay, this one. I would go inside this triangle. I could have been in the lower triangle, but I decided to go with this one. Both of them will work. Okay. So let's say that this angle is theta. How much is theta? We have the triangle 3, 4, 5. Okay, so let's find theta. We have tangent theta. That is equal to the opposite, that is the 4, divided by the adjacent, that is 3. So we got theta that is equal to 53.1 degrees. Let me check. Okay, and a 4 divided by 3. Yes, that's correct. So we have the two dimensions, 0.3, this one. We have this one, and we have the angle theta. Let's use the cosine law to find RD about IC. Okay. Oops. So we have RD about IC. So I'm using the cosine law. So RD about IC square, it's equal to the 0.33 square plus the 0.25 square minus 2 times 0.33 times 0.25 times the cosine of the opposite angle, that is cosine of 53.1 degree. Oops, degree inside. Okay, and when you do that, okay, you find RDIC, that is equal to 0.269 meter. Let me check again. So 0.33 square plus 0.25 square minus 2 times 0.33 times 0.25 times cosine of this angle, 0.269. Yes. So now that we have the RDIC, we can find VD. VD is equal to the omega of BDA times RDIC. So we got VD equal 0. Oops, no, that was not 0. That was 9.09 times 0.269. And we got VD, that's equal to 2.446 meter per second. So we have the velocity of the point D, and we have the velocity of the point VB, of the point B. VB is going to the right, VD is going down and right. Okay. If you want to find the directions, we need to make some to find the angle. Right? Okay, but yeah, I just want to find the. Oops. I just want to find the magnitude. If you want to find the directions, you can find those angles, and you can split with cosine and sine. Okay, so we have VD, so we kind of done half of the work. Okay, now we will go on the road CDE. Okay, so let me draw the road CDE. CDE is a long road like this, at the point C, at the point D, and at the point E there. We know that between C and D it's 0.4 meter. And we know that the angle between the horizontal and CD is 30 degrees. We know the velocity VD. Okay, let's draw the IC. So we add the road. Let me try to do this kind of the same. Point A, that was VA, that was VB. So we kind of have, let me see, VB, yeah, VA is a little bit above. Just don't want to put too much info there. So we put the VA a little bit more to the right, the VB a little bit more to the right, and the VA there. So that was the IC, right? That was the IC of the previous bar. That was the IC of BDA. Okay. So with the IC of BDA, I can redraw VD that I know, right? That's the VD that we know. That is perpendicular to this IC. Okay. So I know that the IC of the CDE will also be on this line there. Okay. And C, if we look at C, VC is necessarily horizontal and it will be to the right. So the IC is somewhere also on this line. Okay, I'm sorry, I will need to remove that. I will move it down. Okay, so I don't lose anything, but I do have space for my new IC. That's the IC of the road CDE. Yes, and they are aligned. They need to be aligned because they have the point D that belongs to both roads, the road BDA and the road CDE. Okay, and this one is VC. So we need to find the new omega, that is the omega of the road CDE. And what do we know? We know VD. How much is VD? We found it before. VD it's 2.446 meters per second. So we need to play with this triangle because we need to find this long distance. Let me make it in purple. That is the new RD about the new IC, the ICBDA. Okay, so we need to find this distance. So what can we use? We need some angle. So we have the 0.4. We have this angle there. We have 30, and we know that this one is 90. So we have a total angle there that is 120 degrees. Okay, and we can find this angle there. Let's call this angle beta. Okay, this angle beta is the same than this one, right? Why is it the same? That's the same angle because the IC are aligned. Okay, so let's to find beta, we can use this triangle. Okay, so let's come back on this triangle to find beta. We can use the sine law. So the sine law said that sine beta divided by the opposite, so 0.25, it's equal to, let's use sine of the theta that we found before, divided by the RD about IC. That is there, that is 0.269. So we got sine beta, that is equal to 0.25 divided by 0.269 times sine theta. Theta is 53.1. Okay, so we play with that and we find for theta, but let's do it. So the inverse, inverse sine of 0.25 times the sine of the 53.13. If you can take the exact number, that would be awesome. Divided by the 0.269. That's, oops, 48.0 degrees. So this angle beta, let's write it on the side, that's 48.1 degree. Yay! So we have angles and we have one dimension 0.4. So we can use the sine law. So we want to find RD about the IC. Okay, IC BDA. So let's use RD about the IC divided by the opposite sine of the angle, so 120 degrees. And this is equal to 0.4 divided by the sine of 48.1 degrees. So we got the RD about IC, the new IC, that is equal to 0.4 times sine 120 divided by sine of the 48. That gives us 0.466 meter. So now we have one velocity and one dimensions between D and the IC. So we can use the formula VD. It's equal to omega of the road CDE times RD about IC. So we know VD, so we have omega CDE. That's equal to VD, the 2.446, divided by the RD about IC. That's 0.466. So omega CDE, it's equal to 2.446 divided by 0.4659, 5.25. Let me check. Just trying to see. Okay. Oh, yes, I see it there. 5.25 rad per second. And we are almost there. We got the omega, so we just need to find some RD, IC. Okay, we have the omega. We have this omega. We found it is 5.25 rad per second. Let's find this dimension. That is RC about the IC. And we will be able to find BC. So to find RC about the IC, we know these dimensions. We need this angle there. Let's find this angle there. So this angle there is 180 minus the 120 minus the 48.1. So 180 minus 120 minus the 48.1. That's 11.9. Right, can you see? Oops, 11.9 degrees. And the RG, but I see this one is 0. That's 0.466. Okay, so we can use a sine law. Let's use a sine law. So we want to find RC about IC. So this one divided by the opposite angle, that's 11.9. It's equal to, let's use 0.466 divided by the sine of 120 degrees. And we got RC about IC. That is equal to, so the 0.466 times the sine of 11.9 divided by the sine of 120. That's 0.111 meter. So that's for this one. That's 0.111. And we can find VC, that is equal to the omega CDE times RC about IC. So VC it's equal to 5.25 times 0.11. VC it's equal to 5.25 times this one. That's 0.582. 0.583. Yeah, and I think I did use a little bit of approximation there. I have the exact value, that is 587. We almost there. Point E. Point E. Let's draw again the road CDE. Point C. Point E. Okay. We know the position of the IC. We know that the IC is 0.111 below C. We know that this angle is 120 degrees. We can draw the line up to C, to E. So we find VC. We know VC there, right? This one will be perpendicular to this. This dimension there is RE, but IC. So we just need to find this one. We have one dimension, one angle. We are missing one dimension. So we need a dimension between E and E. And that's 400 plus 300, 700 millimeters, so 0.7 meter. We have two dimensions and one angle. We think about the cosine law. So the cosine law tells us that RE about IC square is equal to 0.7 square plus 0.11. With the exact approximation, that should be 112. Let me keep it consistent. 111 square minus 2 times 0.7 times 0.111 square cosine of the opposite angle. That's 120 degrees. Don't forget to take the square roots. We got RE about IC. That is equal to, let's check. I check that don't make any mistakes. 0.7 square plus 0.111 square minus 2 times 0.7 times 0.111 and cosine of 120 degrees. That's 0.762. 0.762 meter, that this distance. Okay, and we know the omega. The omega is 5.25 rad per second. So we can write that VE, it's equal to omega CDE times RE about IC. So we have VE, that is equal to 5.25 times 0.762 meter. We got VE, that is equal to, times 5.25, 3.999, so that's 4.00 meter per second. That's the magnitude of VE. If you want the directions, you need to find an angle there, an angle there, and you can report the angle that you found there for VE and use cosine and sine. So let's just come back 10 seconds on what we did. Okay, that's all the steps. We use first the road BDA to find VA. We have VA, so we find omega, we find VB, and we find VD. And second steps, we use VD to find omega, CDE, and VC. And with the omega, we find finally the VE. So it takes some steps, but I don't think it's more difficult than the vectoral formula with the VB equal VA plus omega cross product of RB about A. I think I like the IC too. So thank you for watching, and I wish you a good day. See you soon. Bye bye.